Question 12. Find the distinct complex numbers z such that z to the power of 4 is equal to 1 over 32 root 3 plus I. So again, if you look at this number, root 3 plus I, you can see what this is going to give us already. Like you can probably figure out where I'm going to go with this. I'm going to look at this on the Argand diagram. This is root 3. This is 1. And, oh gosh, oh well, just change that. This is 1. And this gives us a triangle, right? Where this is root 3, this is 1, so this is going to be 2, and this is going to be, this is the shorter side, so this is pi upon 6. This is pi upon 3. Right? So I can say already that, and this is of course I'm going to be using de Moivre's theorem because I see I'm going to be taking a fourth root. But the first thing I want to do, I want to be able to write an exponential, so the first thing I'm going to do is I'm going to write this complex number as an exponential. So that's why I make this observation at the start. So that tells me z to the power of 4 is equal to 1 over 32. And this number is 2e to the I pi upon 6. Right? So what do I do? Well, this is actually not too bad. So z is equal to, and this is 1 over 16 e to the I pi upon 6 to the power of 1 over 4. And of course, I remember this isn't just pi upon 6, this is pi upon 6 plus 2k pi. So this is, and then 1 over 16 is actually 1 over 2 to the power of 4. So this is just going to be 1 over 2 e to the I pi over 24 plus, remember I had a plus 2k pi there, so that also gets divided by 4. And I should also declare at this stage that k is an integer. So actually this can do me almost. All I have to do here is just, pretty much leave it. This is my answer. Z is equal to 1 over 2 e to the I pi upon 24 plus 1/2 k pi. And then I should choose some values of k so that they know that I know what I'm talking about. I want the values of k that give me an argument, this part up here, in the principal range. And I hope you can see that the smallest I go, if I put k equals to -2, I get pi upon 24 minus pi, and that will be just bigger than minus pi. So that's the first one I'm going to choose, -2, and then I just take the next 4 values above that. So this is my answer. Part B, find the fifth root of this complex number. So you can see this is a number divided by its conjugate, so that's going to help us out a little bit. And actually we know what the top line is already, right? Because the top line is the number that we were using just before. The top, so what is, okay, I'm rambling a bit, but we want to solve z to the 5 is equal to root 3 plus I over root 3 minus I. And I've just realized that, no, sorry. Oh yeah, it is the same. So we know the top line. So this is the same thing as z to the 5 is equal to, and the top line is 2e to the I pi upon 6. And then the bottom line is just the conjugate of the top line, right? So this is also just going to be 2e to the I minus pi upon 6. So replacing the argument with its negative. And so z to the 5 is equal to e to the I pi upon 6 minus negative pi upon 6 is 2 pi upon 6 is pi upon 3. So what do I have? That means that z is equal to e to the I pi upon 3 plus 2k pi, whole thing to the power of 1 over 5. So k here is a integer. And then what do? Well, I just move that in. So this is z equals to e to the I pi over 15 plus 2 over 5 k pi. And then I look at the values of k that I can use. So the smallest value again that you can see here is k equals to -2, because -3 it'd be too big already, too small already. So -2, -1, 0, 1, 2. The 5 values up from -2. So C part 1, find the cube roots of the complex number 1 plus I root 3, giving your answer exactly in the form re to the I theta. So again, we look at this number, 1 plus I root 3. Well, what does that look like on our Argand diagram? Again, we know this is in the first quadrant because both terms are positive. This is 1. This would be I root 3. So again, you can see I've got a triangle here of length 1, length root 3. This would just be pi upon 3 because it's the bigger angle now. Right? So I'm asked to find the cube roots of this complex number. So that means I'm asked to solve z cubed is equal to 1 plus I root 3. And that is equal to, and this is a 1, 2 root 3 triangle, so this would be equal to 2e to the I pi upon 3. Right? And of course, actually, this is not just pi upon 3, it's pi upon 3 plus 2k pi upon 2k pi. So I can write z is equal to 2e to the I pi upon 3 plus 2k pi to the power of 1/3, and k is an integer, right? So what does that give me? This gives me z equals to the cubic root of 2 e to the I pi upon 9 plus 2 upon 3 k pi, where k equals to what? And again, we look at the possible values we can take. Here we can't take k equals to minus 2. That would be minus 4 pi. Minus 4 over 3 plus 1 over 9. That would still be smaller than minus 1. So I take the next one I can choose, minus 1. So if I substituted minus 1 in here, I'd get an answer that's bigger than minus pi. So it's minus 1, 0, and 3. 3 terms up, right? Okay, last one in question 12. Hence, solve the equation. This is where it gets a bit fun. Hence, solve the equation z to the power of 6 minus 2z to the power of 3 plus 4 equals to 0. So clearly we're talking about some sort of quadratic here, and this is in fact a quadratic in z cubed. So using the quadratic formula, I get z cubed is equal to 2 plus or minus the square root of minus 2 squared. Take 4 by 1 by 4. All over 2 by 1. And this is what? So this is 1 plus or minus the square root of 4 minus 16 is square root 12 over 2. Square root 12 over 2, this is of course 1 plus or minus square root 3, I, minus 12. Right? Okay, good. So we've got two possible solutions. If z cubed is equal to 1 plus root 3 times I, then we actually already have the solution, right? So we can take our solution from C part 1. Or if z cubed is equal to 1 minus root 3i, well, actually, this isn't too much different. We're just going to get, if you look at it, this would be 2e to the I minus pi upon 3 plus 2k pi, where k is an integer. And actually, other than that, everything else would remain exactly the same when I took the cube root. So therefore, so this part here, I'm just going to say C part 1. So therefore, we get z, therefore, z is equal to the cubic root of 3, cubic root of 2, e to the I, pi upon 9, plus 2 over 3 k pi, or z equals to the cubic root of 2 e to the I minus pi upon 9 plus 2 over 3 k pi. But either way, k is going to have the same three values, minus 1, 0, and 1. And so that is our answer.